Hello everyone, today we're going to go over the blind 75 in C++, and today we're working with the problem counting bits. Now before we get started, if you're following along, feel free to pause the video for whenever we are dealing with any of these types of questions. We always need to ask ourselves these 4 questions: what the input's going to be, what data structure / algorithm / technique to use, what to do with the data, and finally what our output's going to be. So again, feel free to pause the video if you're following along to write out these comments to be able to go over the questions. Go over the questions right now. Given an integer n, return an array of, which is called answers, of length n plus 1, such that for each index between these following constraints, answer at the following index, answer I, is the number of ones in the binary representation of I. Okay, well, it looks like from here we have our input of n, and we need to return an array based on the length of 2, and arrays typically start at 0, so 0, 1, 2, based on binary representation. And we have 0, 1, 2, 3, 4, 5 of that array as well, since arrays typically start at 0. 0, and it looks like our output is we need to return an array of binary representation of, looks like for each one, and for each index, the number of ones. Okay. Return an array of binary representation of I. Okay. I based on the number of ones. And it looks like input, we are given an integer num. If we were to go over these 2 examples that we have over here, so if we were to have the binary representation of input n equals 2, we have the array of 0, 1, 1, we need to return the number of ones in the binary representation of each number accordingly. Okay. We need to return the binary representation of each number. The index of each array will contain the total number of ones for each number. For example, if we have n equals 2, our output is we don't have any ones in the 0 index. We have looks like 1 in the binary representation of 1. And then we have 1 in 10 for the binary representation of 2. So 0, 1, 2, 10. There is only 1, 1. We have 1. There is only 1, 1. 0. There is no ones. There are no ones. Okay. And if we were to expand this even further for the other example, our input and output being 5, and then input is 5, output is an array based on the index of 5, and then we have 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. It's 0, 1, 10, 11, 100, and 101. We first have n, then we have to give the binary representation of it, and then finally put in the number of ones of the binary representation in the array. So we don't have so for 0, we don't have any ones, we just have 0. So it's right here. We have a 1, 1 right here. We have 1, 1 here. Then for the binary representation of 3, we have 11, where we count the number of ones, where it will be 1, 1, and that means we have 2 ones for the binary representation of 3. 3. So that's why 2 will be 3. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, In 4, there is only 1 in the binary representation of 4. So therefore, it will be 1. And then for 5, there are 2 ones for the binary representation of 5. Oop. So therefore, it will be 2. There we go. Sorry about that. So there are 2 ones accordingly right here. So it will be 2. Then we have 1 for the binary representation of 4. And then there are 2 ones for the binary representation of 5. So therefore, that's where you put 2 here at the index. And arrays typically start at 0. 0, 1, 2. 0, So 1, 2, etc. All right, and the steps for us to be able to accomplish the following task is that the following technique that we are going to be doing for this is that we are going to be using dynamic programming to loop over each number from 0 to the given integer. And the steps for us to be able to do this, to accomplish this, are going to be the following. 1, we're going to create an array to store the counts of 1 bits. Step 2, we are going to loop over each number from 0 to the given integer. And inside of our loop, we are going to calculate the count of 1 bits for the current number. And then we're going to store the count in the array at the specified index. Finally, we will return the array. And so the way it's going to look like, just going to clean this up. Step 1, step 2, step 3. Is that for our following steps up here. Step 1 is going to look like this. So we're going to have a vector of integers as they specified before. Call it count. Since we're counting the number of ones, which are the bits, which will be num plus 1 to 0 at the given index that we have that to first initialize. And then we're going to loop through our given num array. So for int I is going to be at 1 at the very first index that we have, because we assume that it's already 0. Then I is going to be less than or equal to num, since we're scanning through the entire array. Num, not nums. Okay, and then I plus plus. Then for A, and then also B, this will be the same. So at the following index for counts, it's going to equal counts of I. We'll be getting the bit representation of it, and then we will calculate the count for the number of ones that are there, and finally return our counts. Okay. Calculate the count of 1 bits. So that means convert the number at the index to its binary, then store the number of ones in the array. the counts array. So this part, we are getting the binary representation, and then we are also storing everything into our counts array. So let's run this. Okay, passes all the test cases. And it works. Okay, so just to give a rundown and breakdown of our space and time complexity is that the time complexity for a solution is going to be relative to the size of num. So it's going to be O of n, where n represents the num of the given non-integer that we are already given, such as, so the bigger the integer we are given, the longer the program will take, and so that's why it will be O of n. And meanwhile, the space complexity is also going to be O of n, where n represents num, which would be a non-negative integer that we are given, and we have to give the solution an array of a size based on nums plus 1 to store the counts of 1 bits for each number. And so yes, this was counting bits in C++. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put in the comment section. And as always, take care. Cheers. Bye-bye.